Students, before we leave the topic of a simple sine wave, we would like to touch upon another important concept, which is of wavelength. Students, हमने amplitude को देखा. We looked at the frequency, and then we looked at the phase. Students, wavelength is the amount that a waveform or a sine wave travels in one period. Once again, it's a very important concept, and you'll find out why in the later discussions. But it's a concept that binds the frequency of a sine wave with the propagation medium. Frequency को जब हमने study किया था तो हमने ये देखा था कि frequency does not relate to or depend upon the propagation medium, the medium in which a particular sine wave is propagating. The wavelength binds the concept of a propagation medium with frequency. Students, एक slide पे एक figure की जानिब चलेंगे and we'll try to understand this concept of wavelength further. Students, as you can see in this figure, I'm showing you a sine wave at two different intervals. At time t, in a particular transmission medium, we have got our sine wave or our periodic analog signal. And then the second snippet shows the same sine wave at time t plus capital T, where capital T, as usual, represents our period. So what has happened is that essentially the waveform in a particular transmission medium has traveled one period from time small t to time small t plus capital T, once again where the capital T is the period of this waveform. Students, in this particular case, as you can see, the wavelength is represented by the difference of the position of this waveform at time t, small t, and time small t plus capital T. Students, as you have already been told, the frequency of a signal is completely independent of the medium in which the waveform is propagating. That is not the case with the wavelength. Wavelength is the property of any type of signal which is completely dependent on the direction of the propagation as well as the properties of the propagation medium. Now students, let us try to calculate wavelength or try to find out how can we calculate wavelength given the propagation speed and the frequency of a waveform. Students, the first thing that we need to calculate the waveform is the propagation speed of a wave. So this propagation speed is, for example, if we are talking about a simple waveform that we deal with in everyday real life, then this propagation speed is nothing but the speed of light. The second thing that we need is the frequency. So we represent the frequency as usual by small f. Now wavelength is represented by a symbol which is called as lambda. This is how it's represented. So students, if we represent the speed of light by c, frequency by f, and wavelength by lambda, then our wavelength is essentially equal to our speed of light divided by frequency. So given that this c is constant, so it's the speed of light is 3 into 10 raised to the power 8 meters per second. If you have got frequency, divide the speed of light with the frequency given and you can find the wavelength. Let's try to do that for the red light. Now in the case of red light, our frequency is 4 multiplied by 10 raised to the power 14. Now if you do the maths, this comes out to be equal to 0.75 into 10 raised to the power minus 6 meters, or 0.75 micrometers.